So we're going to get started. So thanks everyone for joining us for today's webinar on artificial intelligence, engaging your customers through AI. I'm Stephanie Way, the Manager of Communications here at CSIO. With me is Michael Fire, CSIO's Broker Relations and Communications Specialist. He'll be helping out on the technical end and moderating any questions that come in. If this is your first time joining us, welcome. So CSIO's mandate is to improve the ease of doing business in the broker channel. We maintain the data standards in CSIO.net that facilitate data exchange in the P&C industry. In addition, we also support you by helping to educate and improve brokers' digital competencies like this webinar. If you haven't already signed up on CSIO.com for an account, I encourage you to do so, and you'll get added to our monthly newsletter to find out about upcoming events like this and educational opportunities, and to find out about all the work we're doing. So first, just a few housekeeping items. So all participants on today's sessions are muted. You're in listen-only mode. If you want to minimize the panel screen that appears, you just need to click on the orange arrow to minimize it. If you want to ask any questions, you can do so at any point in the questions pane in that panel. And we'll hold questions till the end, and Michael will moderate, and we'll answer any questions as time allows. I'd like to take the time to introduce our wonderful guest panelists, and thank you again for joining us today. So Charles Finley is the Global Director of Marketing and Communications at IBI Group. He's a strategist, designer, entrepreneur. He holds corporate, executive, and community nonprofit board roles. He co-founded and is also the board chair of Code for Canada, which is the country's leading civic tech organization that brings design and technology together for public good. Charles is as I said, the Global Director of Marketing and Communications at IBI Group, a global architecture, engineering, planning, and technology firm. He is responsible for the firm's digital, brand, and communication strategy. He's led transformational digital change through building teams and delivering on strategic initiatives and global roles with Mars Discovery District, Thomson Reuters, and Critical Mass. He's also served as he also serves as Vice Chair of Waterfront Toronto's Digital Strategy Advisory Panel. Our next panelist is Stephen O'Brien. He specializes in requirements analysis, design, and implementation of real-time software applications, particularly in the area of toll collection systems. Stephen's the Director and Senior Practice Lead, Intelligent Systems and AI Technology Stream Lead at IBI Group as well. And Lindsay Ellerby is the Senior Design Director at Normative Design. She is a designer who excels, in her words, excels in the messy overlap between business, technology, and human context. Throughout her 10-year career, she's honed skills in information architecture, interaction design, design research, and strategy. Since joining Normative in 2009, she delivers strategic and tactical leadership on a range of projects, everything from design and software development to creating strategic roadmaps for clients. Lindsay also founded and leads Toronto's Design+AI monthly Meetup, which examines the implications of AI in business and design. So welcome again, and thank you for sharing your time and expertise with us. We're really excited for you to give us a peek into how AI works, applications in the real world, and some case studies. And with that, I'm going to pass the baton to Charles, who will start us off.
Good afternoon, everyone, and thank you for spending time with us this afternoon to talk about artificial intelligence. I hope everyone can see my screen. I am projecting right now. We start off a little bit, just a very quick kind of overview of IBI Group. So we are a globally integrated design and technology firm, and we plan, design, build, and sustain the cities of tomorrow alongside local communities across 6 continents. We have over 2,500 staff. We have 60 offices on 6 continents around the world. And in 2017, we had 1,682 projects in flight. Our core services are really around architecture, interior design, engineering, landscape architecture, planning and urban design, and we have a very, very robust systems practice that brings technology into everything we do in the built environment. So a lot of the work we're doing right now on the AI front is looking at how we bring artificial intelligence into smart cities, into traffic control systems, into buildings, and basically taking our intelligence practice and turbocharging the rest of our practices. And so that's one reason I think Stephanie thought we might be there's similarities between industries. Our industry is being disrupted just as the insurance industry is as well. So we do pretty much anything to do with the built environment, IBI Group does. So with that, I'm going to turn that over quickly to Steve O'Brien to talk a little bit about the basics of artificial intelligence.
Thanks, Charles. Thanks, Charles. Yeah, we just thought we'd start the presentation off just giving some groundwork on what AI is, how it can be used, and the theory behind it. So the AI, artificial intelligence, is just software that simulates what human intelligence does. Things like reasoning, problem solving, perception, vision systems, things like that, using software to do things that we humans kind of do. One thing that AI is not, it is not a rules-based programming of our traditional software that we build. It has no explicit rules. There's no logic that's being put into it that you define. It learns and through experience and through training of what it should do. So it's not deterministic. It means that the results will vary depending on the data that you put into your systems. So if you do not have a proper and diverse data set when you're training an AI system, you'll get skewed results. If I take white males as my data set and program an AI, I will get results that will tend towards what white males will. It won't recognize female or other types of demographics. So you have to make sure that you have proper data going into these systems and verify the results that come out at the other end to make sure they're representing what you want to have happen. How does AI work? There are many different types of AIs. We're just going to talk about primarily one, which is machine learning, but there are others such as cognitive, which is the vision and speech and sensory systems that you see. So what you're driving around in your car right now and you have emergency braking, that's using AI as part of a vision system to detect objects in front of the vehicle. Machine learning is probably the most common one that people hear about, which is either training or experience of software based on data that it's fed. And then there's deep learning, which is a more advanced version of machine learning, which is more closer to mimicking the human brain. But we'll focus on machine learning because that's the most common one that we see today. So there are a couple of different variations on machine learning, but the two primary ones are, one is reinforcement learning, which is very similar to this little toddler learning to walk here. AI, when it starts out, doesn't know anything. It doesn't know how to walk. It doesn't know how to talk. It has to be trained. And so like this little guy here, he has to hold on to the couch and hold on to his dad's hand to be able to walk around. And the way he does that is he takes an action, he'll get a result, so he tries to stand up and he falls back down. And he'll get a reward or a feedback that'll reinforce that particular action. If he stands up and he's able to take a step, he'll continue doing that. If he falls over, he'll try something different. And so there's this feedback mechanism that goes into the AI software, just like this 2-year-old learning to walk, that it will sort of migrate and trend towards the best result and be pushed away from negative results when things happen. One catch with that is it can end up, the AI, when it's starting to learn, it can get stuck in a certain behavior that it needs to be pushed out of. So like this little toddler, he's learned to walk by holding onto the couch and holding onto a hand. Well, that gets you so far, but you're going to have to let go of his hand and have him not touch the furniture to learn further. Same thing with AI. It may learn a certain pattern, but you have to push it, nudge it into a different direction to get the actual result you want. So this is a variation on reinforcement learning. A second one is supervised learning. Like the little girl here, you show a picture of a dog or a cat and you reinforce that with them saying, here's a picture of a dog and that's a dog. Here's a picture of a cat and that's a cat. So you provide training data. And in terms of training an AI system, it's not a few cue cards that you need thousands and millions of audited pieces of data to be able to train that system. So I need to show it 1 million pictures of a dog, and I need to show it 1 million pictures of a cat before it starts to pick up those patterns. And it's correlating those inputs, so it'll look at the, the nose, the ears, the eyes, the paws, and it'll see those things, and it will iterate through those patterns and come up with, when I see this combination of ears, eyes, nose, that's a dog. When I see this combination of ear, eyes, nose, that's a cat. And so big data, and that's why Amazon and Google are very interested in lots and lots of data, because that's what they use to train their AI systems. And as you feed more data into it, the more the system will improve. What's going on behind the AI system is there's a neural network. And the neural network is really just a black box, and you're giving it a set of inputs, and then there's a hidden layer, which are those red and green dots, where it's working out probabilities. So if I see an animal with a long nose, and I've been told that that's a dog, I have a high probability that when I see a picture with an animal with a long nose, that will probably be a dog. If I see something with long whiskers, there's a high probability that that will be a cat. And in this example, if I see training it to detect a type of vehicle, if I see 2 axles, well, there's a 10% chance that that's a truck. If I see 5 axles, there's a 95% of a truck. And then if I combine that with another input of how high that vehicle is, if it's a low vehicle, it's less than 2 meters tall, well, it's a 10% chance or greater than that, it's about a 10% chance that it's a car. So by combining these probabilities, the neural network will give an output to you and saying, when I see this picture, I give an idea that that's probably 70% that's a chance that that's a car, and it's a 10% chance that it's a truck. So it's not giving you an absolute answer, it's giving you a probabilistic answer based on the data that's been fed and trained on. Now, who is working with AI? So all the major universities, University of Toronto and Waterloo in Canada, Carnegie Mellon, Stanford, Berkeley in the US, and University of Edinburgh, and just about every university has some sort of program in AI research. On the corporate side, all the major players, Amazon, Google, IBM with its Watson program, and Microsoft. We were recently at a conference with Microsoft. They have 8,000 researchers, and they're spending just $3 billion on salary alone in AI research. So there's a huge amount of knowledge being generated by the universities, and the corporate side investing in research to give us products that will help us use AI tools for our different businesses. What are examples of AI? This is an interesting one that was done by KPMG. They took a survey of 3,000 fast food restaurants in the UK, and what they looked at were different inputs. So the inputs could be something like there's a tube station nearby, something is obstructing the view of the front of a station, there's museums, movie theaters, a school nearby, and what type of socioeconomic demographic is in the area. And they ran those 3,000 locations, put all that input data, and they were able to create an AI model that if I gave it a new location and put those inputs, it could predict what the revenue stream for that restaurant would be to help the fast food restaurant pick the optimal location to open a new restaurant. And what some of the things that it helps them do is it eliminates human bias. One of the findings that came out of this study was that pickpocketing, petty crime, was actually a good sign for locating a restaurant, because it meant there were tourists nearby, there's lots of money going around, so it was actually a positive indicator, whereas the human bias would be, there's criminal activity in the area, that's where we would want to avoid. In this case, the AI detected a pattern saying, oh yeah, pickpockets are actually a good sign to locate the restaurant. So this is helping that fast food restaurant, working with KPMG, pick better locations for their restaurants and maximizing their revenues. Google, everyone knows about Google's work in self-driving car, and Tesla and other manufacturers like BMW, Mercedes, and Cadillac. There's an important difference between what Google is doing and what the others are doing. Tesla, Cadillac, Mercedes, they're all doing driver assistance. So they're providing subsystems in your vehicle to help protect you. So they do like lane keep assist, emergency braking, blind spot warning. Those are all sort of detecting things around you. Google is actually working on the self-driving car, and it takes a much different approach to do this. So if you look at that image in the lower left of the picture there, it shows a bunch of vehicles. There's a cyclist, there's a construction zone, cars and trucks, traffic signals. The Google vehicle, when it's driving around, it has to use vision AI, radar systems to detect and classify all the objects in its environment, which is very similar to what Cadillac and Tesla and Mercedes are doing. That's the starting point for its self-driving technology. The next part, and this is the big difference between what the others are doing and what Google's doing, is you have to then figure out what those objects are going to do. It has to learn what other actions, so what will a squirrel do, what will a baby do, what will a toddler do, what will a car do, what will a motorcycle do. All those things have to be learned. And so that's that reinforcement learning we talked earlier about in machine learning. It needs to figure out what each vehicle could possibly do, anticipate that, and then take the appropriate action. In order to get there, Google has already driven 5 billion simulated miles to gather and teach its systems. It's also done 8 million public miles on public roads with their vehicles. It's doing about 25,000 miles a day in collecting new data. Rand Corporation did a study, and they estimated between hundreds of millions and hundreds of billions of miles on actual road would be required to train a system so that it would be safe to use on the roadway. So you can see there is a significant gap. And there was a good presentation by Google, a TED Talk by Google on their self-driving car. And they go, every day you go out, you find something new. He goes, we were driving through Mountain View, California, and we came across a woman in an electric wheelchair chasing a duck down the middle of the road. You know, you cannot train, or you cannot program that in, you have to experience it. And so that's what they're doing. They're just driving miles and learning what vehicles will do and try to anticipate it. On the upside, their systems that they're doing actually behave better than the human drivers, because they will see a bicycle going through, they will anticipate and take a safe action, where the human driver is prone to error and will see something, ignore it, or not see it at all, and take an action that might cause an impact with a cyclist or pedestrian. So it's a it'll be a much safer system once it's in place, but there's a lot of training that's required. The last one, example of this would be for the insurance industry, something as simple like fraud detection in insurance claims. The FBI estimates there's about $40 billion a year in insurance fraud going on. With the AI, when you put through the training data, it can look for patterns in data and look for inconsistencies in those claims and flag those things. So you have a huge training set, you know, here's all these claims that have been filed, and you can classify them as legitimate or false claims, and you put that through the AI engine. It looks for patterns in those data, flags that it'll raise to say, oh, this might be a questionable claim that's being put through. And the ability is it can look at a whole number of claims, and it can process them relatively quickly and flag those for the insurance adjuster to make sure that they're being caught. But it also needs human review. When it flags something, it needs that feedback mechanism from the adjuster saying, yes, you flagged it as a false claim. Was it true or not? And then you feed that back. Yes, it was a false claim. It reinforces the AI engine to properly classify them. Or it says, no, it was a legitimate claim, and then it will correct its algorithms internally to adapt for that. So it's important to have that human component as the review process to make sure it can improve itself. I'll hand it over to Charles now on how it's affecting the insurance industry.
Yeah. Thanks, Steve. So, you know, given all this material, and that's a great last example you gave, is how might this impact the insurance industry, and how might this impact you as brokers and others active in the insurance industry? And the next set of slides are really just more thought starters. So it's like us three are not the experts in the insurance industry. You guys are. But we thought we'd put together a few just thoughts around some things to think about, some perspectives to consider, and many things you've probably are already thinking about. But so, for example, some of the trends currently applicable in the insurance industry, that some of the material we talked about, we're seeing, like with the rise of smart cities and smart devices and Fitbits and phones, and we're wandering through a sea of data that we weren't in before. We've got our buildings are smart, our meeting rooms are smart, and all of these devices are generating behavioral data, some of which are connected to our own behaviors, or some to the behaviors of the function or the efficiency of the car we're driving, the efficiency of the highway that we're on, the safety of the highway we're on. So as you can imagine, with having all of this data available to us in ways that we never had before, this might change the way in which we think about being insured and about safety and about risk profiles, etc. there are a lot more physical robots coming, and they're already in our environment. We have drones. Drones can come to perhaps to a scene of an accident and investigate. Our cars are becoming basically robots or rolling computers, and increasingly self-directed. With all of these different devices and buildings and robots, we're also now seeing the rise of better standards, data standards and ecosystems to allow all of these devices to talk to one another, and a more sophisticated regulatory environment around what we're allowed to, what personal data we're allowed to share and not share. And we still have a ways to go on that front, but things are changing. And then with the smarter technologies, we're also finding being able to sort of look at the data and use predictive analytics and other algorithms and methodologies to be able to actually glean better insight from the data, and actually using automation and other technologies to actually help us act in a smarter way. So those are some of the trends. Looking at some of the changes to maybe consider that might be applied to the insurance industry, things like behavior-based payments, which we're already seeing. So I think the broad trend there is really around moving from proxy data, so basing profiles on what category, say, a customer is, and are they a smoker or a non-smoker, or what age category that they're in, and being able to actually use the source data and using real data about particular customers, and even if anonymized, about real individuals. And so being able to get a better sense of who the individuals are that are being insured and what their behaviors are in a more specified way. It might mean, for example, that, say, for drivers can pay less for policies. So even if they're in a higher risk category, say a young male driver, if they have a better driving record, you might be able to develop a product that gives them a better discount. So they're basically, it's paying what the policyholders would pay what they risk rather than what their risk pool is risking. And I think we're already seeing this. The CAA Connect and CAA My Place are usage-based products that have appeared. And some of the downsides may mean for customers or even for working with customers on these, it's like they may have to provide more of their own personal information to the insurer in order to qualify for that product. So it's like figuring out what that negotiation looks like. Big picture, there's potential for more client-specific or use-specific policies, programs, and products. So a more complex product landscape, basically. A second change is personalization of the customer experience. So it allows, using chatbots and other technologies, you can actually recognize a client more quickly. You can create a better dialogue with those clients. So advanced image recognition and social media can use to personalize your sales conversation with clients. But we've seen a caution on chatbots that if they're not well designed, or if they're, in some cases, I think there was a poll that some customers expressed reservations about purchasing coverage by chatbot because they feel it might be a way for to decline their claims. So it's definitely something to look at, but also to be cautious about in terms of how chatbots work. Client verification can be sped up. So, automatic personal identity verification can speed authentication necessary for quoting and binding. So, it actually can ease your administrative load, and you can have more time working with customers. Carriers, you can also, machine learning can help you customize the recommended coverage for clients, so give you better and more specific recommendations, and brokers can assemble a better suite of products in a package for customers. Finally, and Steve touched on this, faster claims. Some surveys say time to settle is the performance metric customers most care about. So claims settlement can potentially move from days to minutes or seconds, and that is, I think, here in some cases. And as Steve suggested, decreased fraud may also be possible. So those are just some of the changes to think about, many of which you're likely already thinking about, and there's already some products in the market that are doing this. Some advantages. So, I touched on this, but because there's a more sophisticated set of policies and they're more tailored to specific and individualized data, you could be at a competitive advantage over your competitors both from a cost and a coverage perspective if you're able to provide them better tailored products at a lower cost. And with more products and policies out there, it actually increases the need for knowledgeable brokers to help customers navigate that more complex landscape. So I know there's a lot of competition, let's say, from direct, but I think brokers provide an additional value add because to help customers with that kind of landscape. It also provides opportunities for more and better touch points and informed engagement. So automation, they often talk about automation in terms of saving time and effort on administrative tasks. And that is indeed true. And that will allow brokers to spend less time on administration and more time on talking to customers, spending more time with their customers or more time designing out better engagements with them and creating maybe a more modern retail experience. So there's an example of where brokers have taken their offices and turned them into more of a store-like environment. So that's an example of where it's not AI directly related, but the time is freed up for them to do that kind of work. And finally, better risk profiles and claims processing and easier interactions with brokers will build greater trust by customers in the insurance industry in general. So those are some of the advantages that we're seeing, but potentially in the industry from AI. There's some links that we have here, and we can actually pass around some other links that we have that maybe Stephanie and team can pass around to you after the presentation. But next, I want to turn it over to Lindsay Ellerby, where she will be helping to contextualize some of these trends and advantages within some of her experience. So Lindsay, I will turn it over to you.
And
Great,
actually,
thanks, Charles.
Sorry, just to add, if anyone has any questions, again, feel free to continue to send them through the question pane, and we will answer them at the end.
Okay, perfect. Okay, hi everyone. I'm Lindsay Ellerby. I work at Normative, which is a software design company in Toronto. I lead the design practice here. Just a little bit about Normative for context. We're a software design company, and really our focus is to help leaders get their best ideas to market faster. So we're really focused on getting into working software as quickly as possible, really so that we can test out tangible ideas so that our clients can make business and product decisions more easily. So because of that, a lot of our work requires understanding emerging technology, specifically in the realm of software, and its implications so that we can design better software products and services for people. I'd like to share some of the insight that I've gathered over the past couple of years about designing for AI and highlight some of the things that we should think about when using these products or creating them for others. And really, I think a lot of what I'll share today is building on what Charles and Steve were talking about. My slides are a little bit more about some of the themes around the human context with regards to AI and some of the sticky tensions between humans and machines, really. So this is the Amazon Go store in Seattle that allows customers with the Amazon app to take groceries off the shelf, place them in bags as they shop, and walk out the door without going through checkout. Revolutionary grocery store. So the customer's account is automatically charged through the app, and each store item and transaction is digitized. So what this does is it removes the need for the point of sale integration and tagging every can of soup with a code. So not only is the customer getting this very seamless grocery store experience, but Amazon can gather data on what people buy, when, for how much, how often, etc. So this highlights one of the most significant things about AI or any emerging technology, really, and that is that people have changed. Their expectations of technology and everyday experiences has changed. We're in this sort of constant feedback loop with software, with our mobile phones and all the apps that are on our mobile phones, where our behaviors are starting to change because of those apps, and our expectations change, and then those apps are responding with something new and different. So we're in this constant feedback loop, and we're very much, as people, part of the AI process. And what this means for businesses or for insurance brokers or any industry, really, is that there's a new type of consumer, one that is really augmented by technology, a human-machine hybrid, you could think of it as, who really expects instant connection to products and services, highly personalized experiences, and really this applies to every industry. So my field is design, and I work on different software products and apps. And one of the approaches that we take when doing that is we try to start with people to understand what goals, needs, and behaviors they have, and what problems we can solve for them when we create a new product or an app for them. So one of the things that we ask here at Normative is, what job is this product doing for its customers? So in this situation here that we're looking at, the job of the video game that the kids are playing might be entertainment or even education for them. Or another job might be that product is a babysitter so that the parents can get supper on the table with few distractions. So it's this type of research, really examining the human context, that really starts to highlight some of those insightful things about how people behave and what their contexts are like. And really creating products and services that are powered by AI or have machine learning in the background is no different. We want to use that technology to solve human problems. So in the case of insurance, we should be asking, how are insurance customers different now from how they were 10 years ago? Or 15 or 20 years ago? What technologies and devices do they use? What behaviors and expectations do they have? What new experiences are they seeking? And how potentially have life stages changed as people go from different stage to stage in their lives? And then, how can we better serve their needs as customers? Companies like Uber and Airbnb really understand this. They found a human problem. So in the case of Uber, get me from A to B faster, cheaper in many cases, not always, and remove the need for manual transaction. And they really leveraged software, the software ecosystem that people were already connected to remove the middleman and connect two markets, people who need a ride and people who have cars driving around the city, made that really seamless and really disrupted the transportation industry. Now, Uber's product has had some negative results as well, and negative implications. But it's interesting to see how they've sort of changed that business. The next thing here is just talking a little bit about how AI isn't really special or new. I think for me anyway, it can be a very intimidating subject probably because the word intelligence is in there, and so anytime I think we're talking about what is intelligence, and it's a little bit scary to think of machines having intelligence. It's intimidating, and what's helped me in sort of unpacking these themes and understanding AI is to kind of remind myself that it's actually been around for a long time, since the 60s, when some American computer scientist and psychologist Joseph Licklider was writing about computers as communication devices way back in the 60s. And really in the 60s talking about what he called intelligence amplification. So these concepts have been around for a long time. I think the big change is that we've moved from it being in experimentation labs to it being in consumer products. So what we have today is that AI runs in the background on a lot of products that we interact with every day. The Google search field is a really good example of this because it's a very simple execution of a very complex system. And I think most of us use this every day, and I know that I don't often think about the complexity behind it. And its backend is really complex, and it does use machine learning. So I guess the theme here and the sort of reality here is that it is in a lot of products and services that we use every day. So just thinking a little bit more about that, an example where AI is being used daily, running in the background, sort of behind the scenes, is helping people in customer support centers, CSRs, customer support reps, where AI is used to analyze calls and then provide canned responses and help with troubleshooting, so that CSRs can do their jobs more quickly and not have to sift through spreadsheets to find answers to problems. This is a screenshot from a system called LivePerson, which very simple questions can be handled directly by a bot. But as soon as the conversation becomes too complicated, the bot can hand the conversation off to a human. And then the human can handle the more difficult task and maybe potentially more complex human conversation that needs to happen to close out the issue. And they can even hand the call back to the bot to finish up any simple details that need to be finished. So then in this kind of scenario, we can ask, what else can those CSRs do with their time? There's a lot of talk, I think, when we talk about AI around job automation and AIs and bots taking over jobs. I think that the best scenario is with people partnering with technology and really then freeing up the human in the mix to do more complex tasks. And when certain tasks are offloaded to AI, then the human can focus on more difficult, potentially fulfilling jobs. Another example of where AI is being used in the background to help humans build better relationships is Nudge.ai, and this is a service. It has a B2B side to it, business to business. It also has a consumer side. But Nudge is really built around this idea that the reality of our situations today is that we have so much information and so many social and work contacts to keep up with. It's almost impossible to keep up with everybody. And Nudge helps businesses comb through their collective team contacts. So it allows, the system accesses LinkedIn and then really in other social networks and really combs through all of those contacts and determines which contacts are closer than others. And then it helps to surface insights about those contacts to people. So, you could use those insights to build better relationships with potential customers. So these are good jobs for AI products to do for sales teams, for example, in the case of Nudge, for CSRs, acting like a partner to help offload those tedious tasks and surfacing good insights about customers to make more room for us to do potentially new and different jobs. Another example I really wanted to share is Wealthsimple, and this is I'm sure like a lot of you have heard of Wealthsimple or are maybe using the product. It's a Canadian sort of sweetheart startup that's been very successful. And Wealthsimple saw a problem in the financial industry, a large market of people who had a lot of anxiety about their financial futures and really didn't have access to simple information and tools to fix that problem. Steve and Charles were talking about how people just have access to so much data about themselves. We live in the world of Fitbits and mobile phones, and we almost have information overload, right? And so when it comes to managing finances and knowing, how to invest your money, that can be, very sort of nerve-wracking because it's hard to know what tools to use and how to understand that information and data. So Wealthsimple is doing a bunch of things with their product. They're using ETFs and robo-advisors in a really simple application with data that people can understand to provide a better product to people. And it's really disrupting the investment business. One of the interesting things about Wealthsimple is that the service is not pure machine. So yes, there's an algorithmic side to it. They use machine learning and they use automatic trading to balance portfolios. And that results in lower fees to the customer, which is great. But they also have the human investment advisors who customers can talk to anytime. Plus, the algorithm that they have was designed by and is managed by financial experts. So there's a real kind of human plus machine relationship going on behind Wealthsimple that makes it a really effective sort of product for people. Lastly, I'll close with this idea that I was reading about recently, and it's an interesting concept. So there's this concept in machine learning where engineers bake in parameters and restrictions to machine learning algorithms to make them quote unquote stupid and behave more human-like. so that the humans who are interacting with the algorithm feel like it's more authentic, more of an authentic experience. And so it feels a little bit insulting that we need to make some AI as stupid as the smartest human. But the reality is that AI can outperform our intelligence purely because of computing power. So it makes sense to apply these guardrails to make safer AI and to have a little bit more agency over the AI. And so I think that this is an interesting concept, you know, and I think, again, it goes with the whole sort of overall theme of how do we get to a future, or how do we get to a place where machines and humans are working together, and it's not sort of this idea of the singularity. So those were all of my slides. I think I'll just flip to this slide and then I pass it over to Stephanie.
Thanks so much, Lindsay. That's great. So we do have a few questions that have come in, and I'll turn it over to Michael to go through those.
Great. So first question is from Dan. He's asking about the emergence of 5G and 6G networks, and this question is, how will 5G and 6G networks affect the evolution of AI business development in the insurance marketplace? And I guess a corollary as well is, how does blockchain tie in as well?
Actually, yeah, it's a very good question. At IBI, we just had a presentation last week on 5G and AI. The two are very coupled together, and our person who's in charge of our 5G work was saying without 5G, you wouldn't have AI, which I took offense to a little bit. However, but it's very, very true. 5G, for those who are not familiar, right now we're currently working on LTE 4G networks. 5G will take that to the next level, much faster data communication, much more reliable data communication. There's a whole infrastructure that would have to go out there to support that. The whole purpose of that 5G network is to allow us to collect more data about people and buildings and operations and safety, emergency vehicles, ambulances, being able to communicate that information, subway trains, commuter traffic, all those sorts of things. It's allowing us to collect and transmit massive amounts of data. And that's what the AI systems will need. So we were talking about building smart buildings, part of our smart city. If you're equipping sensors into the building so that you can look at how a building is used, the 5G can be used in vehicles, so vehicle-to-vehicle communication for safety purposes. You can be collecting information in real time about the vehicle operation. So when Charles was talking about adaptive policies and based on your use characteristics, that's where 5G would come in. It would be collecting information from the vehicle, seeing how it's being operated, if it's operated in a safe manner, if it's being driven recklessly, speeding, those types of things. It would be able to transmit that data in real time at a high speed into an AI engine. It could flag things to the insurance policy people that you may want to take a look at this person because they could be benefiting from lower claims because they operate their vehicle in a safe manner, or they may require higher rates because they're being reckless in what they're doing. But you would be getting that data in real time. And then tying it into blockchain, again, that's the securing of that data. The blockchain for the very sort of high level, it's basically I take a piece of information, so it could be a shipping container, an insurance claim on shipping. And what you want to do is be able to track where that shipping container went from the source, from the producer, all the way to the retail store, and to make sure that everything was properly handled. So if it was a perishable goods, it was a load of flowers, fresh flowers that had to be delivered in 24 hours and kept at a certain temperature. That data could be collected through a 5G system, is transmitting that data. It's using blockchain to make sure each step of the way is secure. So you cannot alter the data and you can't tamper with the data because the way the blockchain works, each update of that data is encrypted and you cannot change any of the previous data. There's a chain of custody that is maintained of that information, so when you get to the other end, you know exactly what happened to that shipping container. So when you get to the other end and you find out all the roses are spoiled, you can trace back on that blockchain data and find that when it went onto the truck, the air conditioning unit failed in the truck and the temperature in the trailer went up to 90 degrees and that caused the flowers to be damaged. You now have a way of tracking back what that claim was. And the AI engine could be detecting that based on the data from the 5G through the blockchain, goes into an AI engine, and it would tell you exactly what's gone wrong and flag that shipment has been damaged because some shipper along the way made a mistake. And you can then go through that claim process and you have a lot more information as opposed to having to figure out after the fact of what went wrong and trying to be a detective. So all those pieces, gathering the information, securing the information through blockchain, and then running it through an AI engine to analyze that information, all keys to adding efficiency to the business.
Yeah, I was just going to jump in. It's Charles. I have a friend who actually has a startup who basically working at this with blockchain at the supply chain level is able to. It's called fair trade jewelry, and actually it allows retailers here and in Europe and in North America to really be sure about the source of their jewelry, to know that diamonds that they're selling are not blood diamonds, basically. So there's ways in which to secure the supply chain that will actually have a big impact also on the insurance industry, because the way that businesses will be able to secure their supplies and ensure the safety and the sourcing of their supplies and where they are in the system is going to, I think, change quite considerably using blockchain technology.
All right, fantastic. So we had a question come in on chatbots that actually started. It came in just before, Lindsay, you started getting into them in more detail, but I think it still applies. The question is about whether chatbots are more geared towards that sort of algorithmic skip logic versus actually AI, and you did address that. So I guess if the question is, are chatbots sort of predominantly one over the other? Are chatbots on the market where you can buy a more simpler one, or what does the marketplace look like for that range of skip logic to AI in chatbots?
Yeah, I mean, I think that there is certainly a range available in the marketplace, and I think, any organization or individual who's looking to incorporate a tool like that into their workflow needs to really examine, the job that tool will do for you. And, I think some of the better ones that I've seen and the ones I was sharing in the presentation really are running more in the background and surfacing details or insights for the people who are interacting with them, and really not attempting to then take over the conversation. The other thing about chatbots is, and as a consumer, let's say you're interacting with one on a website, it's important and this kind of goes to the artificial stupidity concept. I think it's important for chatbots to reveal themselves. There's this concept also in AI called explainability, and showing the seams and the cracks when something is in fact an AI or a bot is actually really helpful to the human, because then the human knows, okay, I'm interacting with a non-human, system here that has some agency, which is great, and then what you're dealing with. So I think that there's a real broad range of bots out there. If we're using them for our own purposes, it's important to know what will best serve our needs in that mix.
Great, thank you. We have another bit of a two-parter question. So we keep hearing that Canada is an AI leader. So first off, is that actually true? What's driving it? And how will Canadian business benefit from this?
Yes, Canada, U of T in particular is an AI center. No, I was just in a meeting about 5 weeks ago, with a UK operation in the retail grocery market, and they were over here in Canada looking for basically talent and seeing what was being done on the AI field, and they were meeting with U of T and they were also out at Waterloo looking
can be a global business, but we are seeing, we see companies like Shopify and Wave, which are Canadian startups based here in Toronto, who are investing very much in AI because it's starting to underlie much of their business as well. So it is definitely true that it's an AI node. There's some of it's probably hype and marketing, and some of it is true. And I think largely it is true, but you know, it might be overstated in some cases.
And we have a last question, which is for IBI. I think you guys may have found a fan, at least one of our attendees. They're on the IBI website and is asking about the lab that you guys made researching a cure for dementia. They're just wondering if you can elaborate on that because they were fascinated by the concept.
We're just quickly, IBI is a very diverse company. We have 60 offices, so sometimes we have to look up what we're doing ourselves.
Yeah. If it's the UK project, might be the one that they're mentioning. There is some. We have a number of. We have a long-standing healthcare business in the UK, and so out of that business has come a number of interesting developments, one of which is working on dementia. There's an example of a dementia door, which helps. One of the issues with dementia is that people wander, they lose their way, and they're often living in kind of long-term care facilities where they can't differentiate their place from another place. And dementia door allows you to personalize the door with a number of items to allow the person, and the noise, sounds and things, allows the person to find their way back to their home. So that's one thing that's come out of, I don't actually know the details of the lab itself, but if you're interested, I'll follow up, and if you could leave your name, I can contact you directly.
If we can send that to you. And just as a fun aside, I actually saw that door at a design museum in New York earlier this summer, so it's small world, I saw that. And I think the last question we've got, so as data becomes more available and AI evolves to the point where events and processes become predictable and avoidable, would you say that that there will be less need for insurance over time?
That's a big, like the impact on the car industry. From the insurance. If you have autonomous vehicles that are communicating to one another, they will not run into each other. So that will reduce claims, etc. But there are other liabilities that will come out when they do run into each other. Who gets sued? So that's a huge question for the manufacturers. So if you're the Teslas or the Cadillacs or BMWs of the world, your vehicle will make a mistake at some time. It will run into a woman in an electric wheelchair chasing a duck down the road and not know what to do, and there will be an incident. And so the insurance liability transfers from the operator of the vehicle, because people are traditional operators or the drivers. It goes away because you're no longer operating the vehicle, and transfers to the company now, the manufacturer, or the Uber or the Maven or whoever is the person offering the service. So it doesn't necessarily make the claims and the damage will go down, but if there's something that happens, it's transferring that liability to the manufacturer from the individual who used to purchase the vehicle. So very different change in dynamic there of how that gets handled. And you get also into the AI ethics questions of if a vehicle is coming into an incident where, or it has to make a choice, do I hit the school bus or do I hit the lamppost, and do I hit the school bus and maybe potentially kill kids? Or do I hit a lamppost and drive off the road and maybe seriously injure the occupants? There's a whole ethics component of the AI of what you should do when those things happen. And again, that flows back to the manufacturer of what am I going to do when those things happen. So it's an uncharted world that we are entering in as this transition happens.
Lots of food for thought there for sure. Wow. So we're just going to wrap things up. I think you know, we're getting close to time, but thank you for that deep dive. You can tell by the questions there's a lot of engagement and interest. So we do thank you for sharing your expertise with all of us. And for the folks on the line, our next webinar is on My Proof of Insurance. It's next Tuesday, December 11th at 2 o'clock. If you're interested in finding out more about the industry's e-delivery solution, you can sign up at csio.com and check back regularly for our scheduled webinars. They'll be up, the new ones for the first part of 2019 will be up shortly, along with the e-delivery webinars that are already on our calendar. And in addition, also keep an eye out for upcoming CSIO communications coming to you soon on our new e-learning program, which will focus on cybersecurity as our first topic. So again, thanks to all the participants and to our panelists for your time. Much appreciated, and enjoy the rest of your day.